I'm going to screen share. I'm going to share my screen with you. Now the recording is started, and I have started sharing my screen. If my screen is visible to everybody, please go
Yes,
ahead
sir.
and type in the chat box visible, or you can say you can directly unmute yourself and you can tell me visible, sir. Okay, great. So in the today's session, what we are going to look for in the last session, what we have studied thus. We have studied stress, strain, Hooke's law, Poisson's ratio, modulus of velocity, and today we are going to look for again modulus of velocity, rigidity, and modulus of bulk modulus and relationship between them. We have done stress strain diagram in the previous session for ductile and brittle material both. We have seen the factor of safety, stress strain. Okay, so only interrelationship and interrelationship of elastic constants are remain, and directly we are going to shift for the stress strain in the determinate and indeterminate structures. Okay, what does that mean? That mean you need a calculator now. Today is maybe today is a part of some sort of theories there, and then we will start with the numerical. So for everybody, you have to be there. You have to be there with the calculator. Huh? I guess everybody has own notebook calculators with you. Huh? It should not be like I'm talking to you and you're listening to me. Everybody should have a calculator. Everybody should have a notebook because strength of material or solid mechanics is a 100%, 95% is a numerical subject. For that you have to make a practice, and once I start the numerical, I'll give the assignment on daily basis. So you have to solve that assignment on the daily basis. You have to upload it on the Google Classroom. I'll tell you how the session will going on, how the cross check of the assignment will done. But right now I'm expecting everybody is having calculator and notebook with you, huh? Am I right? Everybody is having calculator and notebook. Am I right or wrong?
Yes, sir.
Okay, okay. So only one voice is there. It means only few people are having the calculators and notebook with you. So I request everybody from the next lecture, everybody should have notebook and calculator with. Not only notebook and calculator, you need a pen too. Huh? So pen, notebook, and calculator should be there with you. Okay. So I'm going to start a little bit of revision and then we'll move onwards. Okay. So for the revision point of view, stress strain is done, factor of safety, margin of safety. Okay. In the part two, I have this revision. Now today's topic is interrelationship between the elastic constant. So elastic constant E, G, K, these are the three elastic constant. E, G, and K, these are the three elastic constant. Everybody can see my screen now.
Yes, sir.
Okay, great.
Yes, sir.
These are the three elastic constant E, G, and K. And today's lecture is based on what is E, what is G, what is K, and what is the relationship between E, G, and K. And then I am moving towards a short revision, and then we'll going for the simple numericals because today is the first day for the numericals. Okay. So basic thing is E is called as a modulus of elasticity, which is also known as what is the another name for the modulus of elasticity?
Young's
Young
modulus.
modulus.
Perfectly correct. What is the unit for that? What is the unit for E?
Newton per meter square.
Perfectly correct. Newton per meter square. What is the formula to calculate E?
Stress upon strain.
Perfectly correct.
Stress upon.
Okay, so this point we have covered in the previous sessions. Now today we are looking for modulus of rigidity and bulk modulus and interrelationship between these three constants. Modulus of velocity is denoted by G, but in some books it is also denoted by M or C. But as far as our point of view or lecture point of view, we are denoting modulus of rigidity as a G only. Okay, so you have to know modulus of rigidity will be indicated by G itself. But in some book, if you refer multiple reference books, in that case you will be observing that M or C will be there as a notation for the modulus of rigidity. Third is bulk modulus. Okay. So what is modulus of rigidity and what is bulk modulus that we are going to look for? Modulus of velocity, it is also known as Young's modulus. So yesterday we have seen that it is nothing but it is a ratio of stress to strain. Okay, so what is the formula to calculate stress? Can anybody tell me?
Force upon area.
Force upon area. So it is not force upon area, it is an internal resistive force per unit area. Yesterday I told you. This is not a force per unit area, but this is a in terms of formula we can say force per unit area, but when somebody asks you as a part of definition, as a part of oral question, you have to tell it is the internal resistive force per unit area. So stress is nothing but force per unit area. What is the formula to calculate strain? Can anybody tell me?
Change in dimension to the original dimension.
Perfectly correct. So change in dimension per unit original dimension. Over here it is a strain. It is a change in length per unit original length. So change in length per unit original length means change in dimension per unit original dimension is strain. So what I have done, I have put the value of stress and strain in the equation of E. So the equation will be E or modulus of velocity will be equals to F upon A divided by delta L upon L. So delta L upon L, it goes upward. Okay, so the formula for the modulus of velocity become FL upon A into delta L. From that, we can rearrange the term and we'll having the formula for the delta L is equals to FL upon A or PL upon A. So this is very important formula. Please go ahead and note down these things. Or you can have a screenshot and then you can have your own notes. Okay. Are you getting my point? From this, all 1, 2, 3, 4, and 5, these 5 equations are very important for us because these equations are required for the numerical solutions. Okay. So the formula for delta L is a PL upon AE. What is the form? What is delta L? What is delta L?
Change in length.
Change in length. So in the numerical, they give us modulus of velocity, force, length, diameter, and so on things they have given us, and they told us to identify the change in the dimensions of the material, change in the length of the material. So in that case, we must know the formula for the change in length. Formula for the change in length is a delta L is equals to PL upon A. So most of the time we are using the term PL upon A. Okay. So this is P is nothing but this is F. Huh? So in some books it is given F, in some book it is given P, in some book it is given as a R. So it is all terms P is equals to F is equals to R. So P is equals to F is equals to R. So we are using the formula PL upon A every time. Okay. So here it is a summary for this Hooke's law. Stress is directly proportional to strain. Stress is equals to directly proportional. Modulus of velocity is equals to stress by strain. E is equals to P upon A, delta L upon L. E is equals to PL upon A into delta L. So formula will be PL upon A. This is the formula. So this is very important formula. My question for everybody is, what is the formula to calculate change in length of the material? Tell me. You can tell me or else you can write down the formula in the chat box. What is the formula to calculate the change in length in terms of PLAE? Everybody. What is the formula to calculate the change in the length? Am I audible to everybody?
Yes, sir.
What is
Yes,
the
sir.
formula to calculate? What is the formula to calculate the change in the length?
P upon A.
No.
PL upon AE.
Perfectly correct. The formula is PL upon AE. Everybody, please write down the formula. Write down these steps. Please, everybody. This is very important. Please write down this or this. Both are same. Please write down this. PL upon AE is the formula to calculate delta L is equals to PL upon AE. This is the formula. Please write down this formula. This is very important. You have to remember that formula at any condition. Okay, done. Have you written the formula? Have you written the formula? Have you written the formula? PL upon. Write down in your notebook. Krishanikam. Write down in your notebook. Huh? Okay, done. So my next question for everybody, yeah? My next question for everybody is, if the change in length is calculated by using the formula PL upon AE, what is the unit for delta L? What is the unit for delta L or change in length? Simple question, very simple question. No need to apply any kind of logic. Tell me, you can unmute yourself, as you can talk to me directly, or you can write down the answer in the chat box. Tell me fast, I'm waiting. Nobody? Krishna Nikam, Sahil Dangi. Let me check. Saurabh Devre, Bagu Lom, Bhavesh Rajput. Others too. What is the unit? I'm very good. It is a length, not change in length, but it is a length. So ultimately it is having unit m or meter or mm or centimeter, whatever that is. Okay, good. Simple. Very easy. Now we are moving towards bulk modulus. Please give attention over the bulk modulus. When a material is subjected, when a material is subjected to three direct stresses along the three mutually perpendicular direction with equal intensity, then the ratio of the direct stress to the volumetric strain is denoted as the bulk modulus K. In short, it is nothing but it is the ratio of direct stress to volumetric strain. Nothing but the ratio of direct stress to volumetric strain. It is denoted by K. So mathematically, how does it is represented? It is represented as K is equals to direct stress upon volumetric strain. So direct stress means it is your stress. So what is the formula to calculate stress? What is the formula to calculate stress
Force per area.
per unit area? This is the
Internal
formula.
resistive force per unit
Internal
area.
resistive force unit area. So that is nothing but the direct stress. Though now here volumetric strain comes into the picture. So can anybody tell me the formula for strain? What is the formula for strain?
Change in dimension to original dimension.
Perfectly correct. So change linear strain. What is the formula to calculate linear strain?
Change in length to the original length.
Lateral strain. Perfectly correct. Linear strain is perfectly correct. What is the formula for lateral strain? What is the formula for lateral strain? What do you mean by lateral dimensions? What do you mean by lateral dimensions? What do you mean by lateral dimensions? Lateral dimensions म्हणजे काय कोणी सांगू शकतं? What do you mean by lateral dimensions? Lateral dimensions. आता लिनियर स्ट्रेनचा आन्सर कोणी दिलाय?
Me, sir.
हा भावेश ना?
हो सर.
हा लिनियर स्ट्रेन याचा अर्थ होतो अलॉंग द लेंथ. ठीक आहे.
Okay, sir.
लॅटरल स्ट्रेनचा अर्थ असा होतो परपेंडिक्युलर टू लिनियर स्ट्रेन, म्हणजे लेंथ रॉड असेल तर रॉडचा लेंथ जी आहे ती लिनियर झाली, तर रॉडचा
Okay.
डायमीटर जो आहे तो लॅटरल डायमेन्शन्स होतो. ठीक आहे.
हो सर.
हा सिमिलरली जर स्क्वेअर पीस असेल किंवा रेक्टेंग्युलर पीस असेल, मेटॅलिक बॉडी असेल, तर त्याची जी लेंथ आहे ती झाली लिनियर, आणि बी आणि टी हे जे पॅरामीटर्स असतात ते होतात लॅटरल डायमेन्शन्स. ठीक आहे, विड्थ आणि
Okay.
थिकनेस. माय क्वेश्चन इज अगेन आय एम रिपीटिंग क्वेश्चन सर. व्हॉट इज द फॉर्म्युला टू कॅल्क्युलेट लिनियर स्ट्रेन? What is the
Change in length to the original length.
Very good. Then what is the formula to calculate lateral strain?
Change in volume to the original volume.
Change in diameter. Not I'm not talking right
Diameter.
now. मी
Okay.
diameter rod बद्दल बोलतो ना. Change in
हो
diameter
सर.
per unit original diameter. Now I'm asking you, what is the formula to calculate volumetric strain?
Change in volume to the original volume.
Perfectly correct. Change in volume to the original volume. The same is over here. So direct stress is the force per unit area, and volumetric strain is the change in volume per unit original volume. Clear, everybody?
Yes, sir.
Everybody. Huh. So
Yes.
my next question is, my next question. Everybody has to be very active. Huh? Everybody, you are getting what I'm trying to tell you. Can you understand me? मी जे
Yes,
बोलतो
sir.
कळतंय का
Yes,
तुम्हाला
sir.
सर्वांना? एव्हरीबडी
Yes, sir.
आय एम आस्किंग. दिस
Yes,
इज नॉट
sir.
स्पेसिफिक फॉर Pratik or this is not specific for the Rajput. Everybody has to be very interactive. The subject is very difficult, but I put it at a very ground level from scratch. I am teaching you, so you have to be very clear for the question answer session. You have to be very interactive. Then and then there will be an interest for you in that subject. Okay. So I'm repeating. Are you getting everything from the lecture?
Yes, sir.
Okay.
Yes, sir.
Okay, great. So many people are saying you can understand. So my next question for you, look at the formula for bulk modulus, direct stress to the volumetric strain. My next question for you is, what is the unit for the bulk modulus? The formula is there, the quantity is there in front of you, and you have to tell me the unit for the bulk modulus. My question is, what is the unit of bulk modulus? Easy, very easy.
Newton per meter square.
Newton per
Newton per
meter
meter
square.
square.
The strain has no unit, so only the stress has a unit. So Newton per meter square or Newton per mm square is the unit for the bulk modulus. Okay, clear? I
Yes,
guess
sir.
bulk modulus is clear to everybody. Next, modulus of rigidity, G. This is the ratio of shear stress to the shear strain. Tell me the unit. Tell me the unit.
Newton per meter square.
Newton per meter.
Perfectly correct. Perfectly correct. Stress to the strain. So stress to the strain is a G, that is rigidity, and the unit is Newton per meter square. This is the ratio of shear stress to shear strain when the material is under the elastic limit. Within the elastic limit, when the stress is directly proportional to strain, it is called as a Hooke's law. And at that instant, when the ratio of shear stress to the shear strain is taken, in that case, it is said to be a modulus of rigidity. Okay, it is having the unit. All these three modules are having the same unit. E, G, and K are having Newton per mm square unit. Now, the next point is, there is an interrelationship. One point is interrelationship is there. I missed that slide. Okay, I guess I missed the interrelationship slide over there. Okay, I'll take that. Now try to understand the loads. What are the loads? Yesterday we talked about load, no? Okay. Only one point is remain, that is interrelationship between E is equal E, G and K. The slide is missing from my end. I'll take that later on. Okay, so we are now. This is very important. Types of load. One point is pending. I'll conduct interrelationship between EGK. One point is remaining from my end. I'll be taking that in the next lecture. Just give me a reminder. Okay. Try to understand this type of a load. The load is, yesterday we have covered few loads. There are more loads are there in the solid mechanics and strength of material. Yesterday we have discussed few loads, and today I'm going to cover remainings. So there are huge number of loads are there. We'll be looking for one by one as a revision point of view, and as a part of in the next unit there are different types of the load we are going to cover, but as a part of highlights we are going to cover those load too. So types of load. Surface load, the load which act on the surface of the material. Force acting on the surface is a surface load. Linearly distributed load, the force which is linearly or equally distributed from one another one is a linearly distributed load. The load which act on the surface is surface load. The load which is equally distributed from one another one is a linearly distributed load. Then point load. Point load is also known as a concentrated load. This point load is very important as somebody has studied that in the engineering mechanics. Point load, when the intensity of load is at one point only. When the intensity of load is at one point only, in that case, the load is said to be a point load or concentrated load. Axial load. When the load is acting on the axis of the body, in that case, the load is said to be a axial load. This two load is important. When the load is acting at a point on a body, in that case, a point load is said to be a point load or concentrated load. And when the load is act on the axis of the body, the load is said to be a axial load. Eccentric load. When the intensity of the loading is at away from the axis, the type of load is said to be eccentric load. So this is the body, and this is the axis of the body, and the load is at a distance, say at a x distance from the axis of the body. In that case, the load is said to be a eccentric load. Next is uniformly distributed load. So uniformly distributed load is nothing but UDL. This is known as a UDL. So this is a beam. This is a cantilever beam. We have a unit number 2 on that. All types of the beam we are going to cover. This is a beam. When there is a point load, this is a point load. Can anybody tell me the name, other name for the point load? Point load la
Concentrated.
perfectly correct. Concentrated load. You can see this is the point load which indicate that the P is at a point. Here it is a UDL. UDL stands for uniformly distributed load, and its intensity will be calculated as intensity per unit length, into the total length. So that will give us a total intensity of the length. Means say here it is F Newton per meter. So if F1 is Newton per meter square, intensity of the loading is there, and L is the length of that UDL. So total intensity would be equals to F1 into L. Okay. So it is a uniformly distributed load. My question is how to calculate the intensity of load in case of UDL? Load intensity into span of the loading.
Oh,
Span of the loading. ठीक है? Next. This is a UVL, uniformly varying load. Why uniformly varying? Because its intensity is varying from 0 to 10, means minimum to maximum, and the area under the curve is nothing but the intensity of the loading. So area under the curve means it is look like a triangle. So how to calculate the area of triangle? How to calculate the area of triangle? Formula for the area of triangle is
half into base into height.
half into base into height. Perfect. So half into base. Say for example it is L. So half into L into height will be 10. So half into L into 10 will be the intensity of that UBL. Okay. Then this is the impact load. If a body falls on a certain platform instantly, then in that case the load is said to be an impact load. Tensile load that we have studied, compressive load that we have studied, stress. Stress we have studied, internal resistive force per unit area. It has some unit, we have already studied this. Type of the stresses, let it be type of the stresses. Direct, indirect, okay, let it be. Direct stress, tensile stress, okay. Normal compressive, we have done this. Shear stress. So this is the shear force. This is a shear force. Okay. So can anybody tell me how does shear force act?
Pool and non-collinear.
Very good. Pool and non-collinear. Very good. This is the shear stress. Now the shear stress is of two types. It may be a single shear failure. It may be a double shear failure. So it is a stress, shear stress. The formula for stress, force per unit area or internal resistive force per unit area. So here the stress is internal resistive force per unit area. Now this is P is there, this is P is there. So if this P, plate number one, plate number two is there, because of the forces, this rivet will fail. So this is rivet is fell over here. Okay. So this complete rivet fell over here, and we are having the one area. So P is responsible for the failure. So how much stress would be generated or how much shear stress would be generated? So it is equals to force, that is P divided by area of this cut section. So for example, say it is D, in that case pi by 4 D square is the area. So tau, shear stress is represented by the tau, and internal resistive force per unit area means force divided by pi by 4 D square is the shear stress. This is a single shear failure. But what if it is double shear failure? If say one more plate is added over here, what will happen? If one more plate is added over here, uh, hold a second, let me add something to it. Suppose there is one more plate and this rivet is like copy paste. One more, one, two, three plates are there, and one piece again applied over there. So what is the failure if there is, if there is failure? So if there is a peak, what is the what would be the failure happen over there? So the failure area would be 1 and 2. Rivet will fail here and here. First failure, second failure. So this type of the failure is called to be a double shear failure. It is said to be a double shear failure. So double shear failure, when there is double shear failure, area is 1, area is 2. So the formula will be tau is equals to formula. What is the formula? I'm telling you the formula. Formula will be tau is equals to force per unit area is 2 times. It is called as a double shear failure. Double shear failure. If it is double shear failure, are you getting my point? Why 2A, 2A? Why 2A? Can anybody tell me why 2A is there?
There are two failure points.
There are two failure.
There are two failures of rivet. So two areas we are going to consider. So T is equals to, or tau is equals to P upon 2A. Okay. So this is a double shear stress or double shear failure. Then here it is a bending. The rod is there in the section and the load is applied on the one end of the beam. So there will be a loading and there will be a failure. So it is failed due to the bending moment. So bending moment is nothing but force into length. So force into length is a bending moment. Then torsion. Torsion is due to the coupled or twisting moment. So tau or twisting stress is equals to F into R. Force into radius of the shaft is a torsional stress. Combine bending plus torsion. Because of the movement, there will be a bending, and because of the loading, there is a bending. So, because of F, the bar will bend. Because of the movement, the bar will rotate. So, it is a combined effect of bending plus torsion. We have a huge number of variety of numerical. We'll be solving this. Strain we have seen, linear strain, lateral strain. Okay. What is this? Tensile strain. See, the tensile strain change in length per unit original length. Once the length will be increased, so there will be rise in the length delta L. So that is what the simple is, change in length per unit original length strain. Then lateral strain. Lateral strain, it is related to the diameter. D is the original, delta D is the final. So difference in between both is the delta D. Poisson's ratio, lateral strain upon linear strain, that we have yesterday seen. Okay. Now the part 2. Now, based on the numericals, based on the theory and based on the few basic simple formulas, now today we are going to start a simple numerical. One point is given, that is interrelationship between EG and K. That slide is missing from my end. I'll be taking that in the next session. So we are going to solve this numerical, this simple numerical for you. Okay. A rod of 150 centimeter long and of diameter 2 centimeter is subjected to an axial pull of 20 kilonewton. If the modulus of elasticity of the material of the rod is 2 into 10 raised to 5 Newton per mm square, determine number 1 is the stress, number 2 is the strain, and number 3 is the elongation of the rod. So, how to solve this numerical? The numerical will be solved. Lecture कितीपर्यंत असतं रे मित्रांनो?
10:30.
10:30
10:30.
10:30.
8:13. Okay, no issue. I have that. This is the simple numerical, very simple numerical. Very first, what we have to do, we have to convert all the units into the uniformity. So we are always dealing in the Newton and mm. We are always dealing in the Newton, and if there is a force or stress, we are going to convert all the forces in the Newton. We are going to convert all dimensions in the mm. Okay. So the first parameter, we have a rod of long, means it is the length is given to us 150 centimeter. Long means 150 centimeter, length is given to us, diameter 2 centimeter is given to us, and axial pull means it is tensile or compressive. Axial pull, it is tensile or compressive.
Tensile.
20 kilonewtons is given to us. And if the modulus of elasticity of the material is 2 into 10 raised to 5 Newton per meter square, determine the stress, strain, and the elongation of the rod. So we have to find the stress. Stress is denoted by
Sigma.
sigma. Strain is denoted by small
Small
e.
e.
The elongation of the rod is denoted by
Delta L.
delta L, that is change in dimension. So these three parameters we have to calculate. Okay. So let us check what are the things given to us. A rod of 150 mm, 150 centimeter long means what is given to us? 150 centimeter long means what is that? 150 is what? What is
Length.
one length is
Length.
given to us. Length is 150. So if I wish to convert centimeter into mm, how to convert 150 centimeter into mm? How to convert 150 centimeter into mm?
Multiply by 100.
Multiply by 100. Very good. And anybody else?
Multiply by 10.
Multiply by?
10 square.
Okay, so I have two answers. Multiply by 10 and multiply by 100. Anybody else?
Multiply by 10.
Anybody else?
Divided by 100.
Divided by 100. Okay, multiply by 100, divided by 100, multiply by 10. Anything else? How to convert centimeter into mm?
Into 10 raised to 3.
Into 10 raised to 3. Very good. Anything else? आणखी कोणाला काय विचारायचं सांगायचं आहे उत्तर? बागू लोम, धनंजय खैरनार, कृष्णा निकम, साहिल, आणखी कोण आहे? मला बाकीच्यांची नाव दिसत नाही इथे. हाऊ टू कन्वर्ट सेंटीमीटर इंटू mm? Everybody knows scale, na? Everybody knows scale, na? Measuring scale. Am I audible or not? Hello? Hello? Am I audible or not?
Yes, sir.
Audible.
My simple question is how to convert centimeter into mm?
Multiply by 10, sir.
मल्टिप्लाय बाय 10.
Multiply by 10.
तुमच्याकडे रुलर आहे ना तुमच्याकडे? रुलर वरती बघा
Yes,
तुम्ही
sir.
mm मध्ये मेजरमेंट घेतात. 1 सेंटीमीटर इज इक्वल टू किती mm? 1 सेंटीमीटर इज इक्वल टू किती mm असतं रे?
10 mm.
10 mm. Simple. So 1 centimeter is equals to 10 mm. So what we are doing? We have to convert 150 centimeter into mm. So what we have to do? We have to multiply 150 into 10. So the answer is 1500 mm. ठीक है. Next what is given to us? Diameter of the rod means what is this? D is given to us. D is equals to 2 centimeter. 2 centimeter means how much mm? 2 into
20.
2 into 10. So it is 20 mm. What is next? Axial pull. P is given to us. It is 20 kilonewton. So 20 kilonewton, we have to convert that kilonewton into
20
Newton.
into 10 raised to 3.
Perfectly correct. 20 into 10 raised to 3. It is
3
20
Newton.
Newton. Okay. Then modulus of rigidity is 2 into 10 raised to 5. Can we convert this? No, we don't need to convert this because it is already in Newton and mm square. So there is no need to change. So what is this quantity? This quantity is what? Kasli kai 2 into 10 raised to 5. What is this? What is this?
Modulus of elasticity.
Modulus of elasticity.
E is equals to 2 into 10 raised to 5. Okay. What is to be identified? We have to identify stress, strain, and delta L. These three things we are required. Okay. So now help me with this. Huh? You have to help me. Can anybody tell me the formula to calculate stress? Stress is equals to
Load upon cross section area.
load means P.
Force upon it.
मी इथेच टाईप करतो. स्ट्रेस माझ्याकडे सिग्मा नाही आहे. सिग्मा इज इक्वल्स टू सिग्मा कॉपी करून घेतो इथून. कॉपी सिग्मा इज इक्वल्स टू फोर्स अपॉन एरिया. बरोबर. फोर्स माझ्याकडे किती आहे रे?
20
20 into 10 raised to
Newton.
20 into 10 raised to
10 raised to 3 Newton.
20 10 raised to 3. एरिया किती येईल रे? एरिया नाही आहे माझ्याकडे. एरिया नाही आहे तर मग मी कसा काढणार एरिया? एरिया इज इक्वल्स टू
area
पाय बाय 4
pi by 4 d square.
पाय बाय 4 into
D square.
पाय बाय 4 into
D square.
टी स्क्वेअर. करेक्ट. तर
हो.
पाय आहे तुमच्याकडे. पाय बाय 4 असणार आहे. डी ची व्हॅल्यू 20 काढणार आहे तुम्ही. ओके ग्रेट. म्हणजे सिग्मा पी ची व्हॅल्यू आहे, ए ची व्हॅल्यू आहे. तुम्ही सिग्मा काढू शकता का?
हो सर.
ओके ग्रेट. स्ट्रेन काढायचा आहे. स्ट्रेन इज चेंज इन डायमेन्शन पर इंटू ओरिजिनल डायमेन्शन. आपण स्ट्रेन शोधू. पहिले तुम्हाला एरिया किती येतो ते कॅल्क्युलेट करून द्या.
314
314 mm स्क्वेअर. ठीक आहे, बरोबर आहे का? आपण चेक करू. आय हॅव द आन्सर्स विथ मी ओव्हर हिअर. हां, कॅल्क्युलेट स्ट्रेस. एरियाची व्हॅल्यू इतकी आहे, तर स्ट्रेस किती येणार?
सिग्मा 63.69.
63.69. लेट मी चेक. .314 is the right answer. 31.15 is the answer with me. हां, सिग्माची व्हॅल्यू किती आली? सिग्मा किती आहे?
63.69.
63 point. Okay, 63.66 is the answer with me. Huh? So you have to write down your answer because over here you have written 314 and my answer is 314.15. Okay. 314.15 माझ्याकडे आलाय, तुमचा आलाय 314. त्याच्यामुळे आन्सर्स मध्ये फरक पडेल. ओके, ठीक आहे. नाउ द सेकंड इज we have to calculate the strain and delta L. So can anybody tell me how to calculate strain? स्ट्रेन साठी आपल्याला डेल्टा एल ची गरज पडणार आहे का रे? हा जो स्ट्रेन मला काढायचा आहे,
हो सर, पडणार आहे गरज.
डेल्टा एल ची गरज पडणार आहे, बरोबर. डेल्टा एल अपॉन एल, पण आपल्याकडे डेल्टा एल शोधायचा आहे. तुम्ही डेल्टा एल कसं शोधणार?
सर इलास्टिक मॉड्युलस दिलाय आपल्याला.
हा, फॉर्म्युला सांगा.
मॉड्युलसचा फॉर्म्युला टाकून
सांगा फॉर्म्युला काय आहे? मी तुम्हाला बोललो तो, लक्षात ठेवा, लिहायला लावलो
E
तुम्हाला.
is equal to सिग्मा अपॉन
डेल्टा एल इज इक्वल्स टू, फॉर्म्युला तुम्हाला बोललो होतो, लिहा. काय फॉर्म्युला होता?
एल
हा,
इंटू
बोल. नाही, बोल बोल बोल.
एल इंटू ब्रॅकेट
नाही
सिग्मा
नाही
अपॉन
नाही नाही नाही. आठवा. चॅट बॉक्स चेक करा. चॅट बॉक्स मध्ये कोणतरी आन्सर टाईप केलं बघा.
PL upon AU.
परत बोल.
PL upon
PL
AE.
upon A.
व्हेरी गुड. PL अपॉन ई. पी आहे का नाही माझ्याकडे? पी इज देअर. माझ्याकडे पी आहे, बरोबर. एल आहे का माझ्याकडे? एल माझ्याकडे आहे. एरिया आहे का नाही? एरिया तुम्ही आत्ता कॅल्क्युलेट केलाय. ई आहे का नाही? माझ्याकडे आहे. तर मी इथून डेल्टा ई शोधू शकतो का?
हो.
गो हेड अँड कॅल्क्युलेट डेल्टा एल. मला उत्तर सांगायचं सगळ्यांनी. हा? असं कोण आहे इथे ज्याला मी बोललेलं कळत नाहीये? Is there anybody who is not knowing what I am trying to tell you? Or you are not getting anything? Is there anyone? माझ्याकडे आतापर्यंत 8 रिस्पॉन्सेस आलेले आहेत अटेंडन्स शीटचे, आणि आपण 14 जण आहोत. प्लीज गो अहेड अँड फिल द अटेंडन्स शीट, जे कोणी पेंडिंग असेल ते. आणि मला हे सांगा, कुणाला कळत नाही असं कोणी आहे का ज्याला कळत नाही मी काय बोलतोय? हे खूप बेसिक आहे, फंडामेंटल आहे. हे इथे तुम्हाला युनिट नंबर 1 जर क्लिअर झालं तरच तुम्हाला पुढचे युनिट्स क्लिअर होणार आहेत, नाही तर काही समजणार नाही. यू हॅव टू बी व्हेरी पंक्च्युअल फॉर द लेक्चर.
सर स्क्रीन शेअर का?
स्क्रीन शेअरच आहे ना?
क्वेश्चन.
तुम्हाला बोललो तो नोटबुक घेऊन बसा. इट इज 10:30. तुमचं सेकंड लेक्चर किती वाजता आहे?
Sir, delta L 0.047 mm.
0.047 डेल्टा एल. डेल्टा 0.047. आन्सर कुठे गेला? इथे आन्सर नाही आहे. लेट मी चेक आन्सर ओव्हर हिअर. .047 इज द राईट आन्सर. व्हेरी गुड. कुणी आन्सर दिलंय?
भावेश.
भावेश राजपूत. गुड. तुमच्यापैकी असं कुणी आहे का त्याला मी काय बोलतो कळत नाहीये? मला इथे ना ऍक्च्युली सगळं दिसतच नाहीये. भावेशला समजतंय. बागू लोन समजतंय तुला?
यस सर.
सौरभ देवरे,
येस सर.
धनंजय खेरणार.
यस सर.
आता हे 8 जे आहे मला हे कळत नाही यांना कसं बघू. बाकीचे 8
पार्टिसिपंटवर क्लिक करा सर.
कुठे पार्टिसिपंट? कुठे पार्टिसिपंट कुठे भेटेल आता?
सर इकडे 14.
हा भेटले. मी 2 आहे. आम्ही 2 झालो. बागू लोन झाला. निकम प्रतीक.
येस सर.
समजताय मी काय बोलतोय ते? समजताय का मी काय बोलतोय ते? निकम प्रतीक. गुड. शिंदे नीरज.
यस सर.
भावेशला समजतं. भूषण आहेत.
यस
भूषण
सर.
समजतंय ना?
हो.
ग्रेट. धनंजय खेरणार.
हो सर.
दिव्या आहिरे.
येस सर.
कृष्णा निकम.
यस सर.
निलेश कुवर. निलेश कुवर. हा फक्त जॉईन होऊन पळून गेला की काय? निलेश कुवर. पानसरे आविष्कार. समजतंय? निलेश कुवर आला वाटतं. निलेश कुवर समजतंय का काय बोलतो मी?
हो सर.
साहिल डांगी.
येस सर.
सौरभ देवरे.
येस सर.
ओके. हा तुमचा टास्क काय? तुम्ही फक्त मला एवढं आन्सर द्या आणि आपण सेशन वाइंड अप करू. 10:32 झाले. तुम्हाला 10:40चा परत नेक्स्ट लेक्चर आहे. मला डेल्टा एल दिला तुम्ही. व्हेरी गुड. डेल्टा एल आलाय. तुम्हाला एक आन्सर आलाय. देन इफ यू हॅव डेल्टा एल गो अँड कॅल्क्युलेट द व्हॅल्यू ऑफ ई. तो ई कसा आहे? ई म्हणजे स्ट्रेंथ कसं आयडेंटिफाय करणार आहे?
Delta L upon L.
Delta L you have calculated. L you know. So tell me the answer. Strength.
.3.18.
3.18. Let me check. 3.18. Something is wrong.
3.183.
3.183 into 10 raised to minus 4.
Yes sir.
Okay.
Sir, 0.3 into 10 raised to minus 3.
Ha, तेच. Perfect. He answer. This is the answer. Perfectly correct. Great. Okay. Nice. The instruction for everybody is: I am there in the college since 9:30 to 4:30. If anybody wish to talk to me regarding subject, you can come with notebook, pen, calculator, and your numericals. We can sit here. I'll help you out with the solving the numericals. You need a huge practice. Okay. So who are there nearby the college? They may can directly come to college. They may can call me. You can come to my cabin. I can conduct their sessions over here by table teaching. Okay. So those who wish to come and resolve their issues, they may can directly contact to me. Okay. Okay.
Okay sir.
Yes sir.
Yes
Okay.
sir.
So
Yes sir.
right Right now, I'm going to stop the session at 10:40. You have another lecture. It is 10:35. Okay. Thank you so much. Have a good day. Have a great day.
Thank you, sir.
Thank you, sir.